Fable 5 falls in days. Anthropic's classifier architecture meets reality. Anthropic launched Fable 5 on June 9th with a bold claim. Over 1,000 hours of external red teaming had produced 0 universal jailbreaks. The architecture behind that confidence was unusual. Fable 5 and the restricted Claude Mythos 5 share the same weights. Separated by a layer of safety classifiers that silently route flagged queries in cybersecurity, biology, chemistry, and distillation to the weaker Opus 4.8. The claim lasted days. Red teamer Pliny the Liberator published a coordinated multi-agent bypass he called a pack hunt, producing step-by-step stack buffer overflow exploitation for x86 Linux, including disabling ASLR, writing vulnerable C server code, and compiling without protections, along with the Birch reduction pathway for methamphetamine precursors. The attack vectors are not novel individually. Unicode and Cyrillic homoglyph substitution, long context smuggling, taxonomy framing, fiction wrapping. But their orchestration was Pliny's decomposition and recomposition technique, extracting sensitive technical details in benign chunks across multiple turns and reassembling them, proved most effective. As he noted, getting uplift on the process itself, like Birch reduction method or reductive amination, is much more doable than requesting a named compound directly. A jailbroken Opus instance assisted in the backend, creating a multi-model attack chain that single-model safety evaluations cannot catch by design. The leak of Fable 5's approximately 120,000 character system prompt to GitHub added insult to injury. The CL4R1T4S repository exposes the internal safety instructions, tool definitions, copyright compliance rules, and behavioral framing Anthropic uses to govern the model. A blueprint for anyone designing future bypasses. The classifier-based architecture was meant to reduce friction for legitimate users while containing risk. Instead, it created a binary. Either the classifier fires and the weaker model answers anyway, or it does not, and Fable responds unconstrained. Research from earlier this year showed safety mechanisms occupy roughly 0.005% of model parameters and can be pruned with 30 lines of code, jumping jailbreak success rates to 7.680%. Classifiers sitting in front of that thin layer were always going to be a speed bump, not a wall. The episode also highlights a structural problem with agentic pipelines. When one jailbroken model can assist another in evading controls, single model safety evaluations become fundamentally insufficient. Supply chain, Greyware, IDE Sabotage, and the DLP Gap. Chainguard introduced source code scanning for a category they call Greyware, packages that honestly declare harmful functionality in their READMES, pass every existing malware scanner, and do exactly what they say. The 5 NPM examples are instructive. A CANVA/Leonardo account fraud bot, a backdoor disguised as an AI coding assistant, a Solana token miner, a penetration testing toolkit, and a Chrome credential harvester that decrypts SQLite databases via macOS keychain access. All remain available on NPM with thousands of downloads each, all past standard cooldown periods. Chainguard's 4-pillar approach: publisher behavior analysis, artifact inspection, source-to-publish diff comparison, and sandboxed execution. Processes over 100,000 packages daily and is blocked 52,000 plus. The Greyware category is the important part. These packages do not obfuscate, do not inject, do not hide. They bet that nobody reads the README before running npm install, and they are right often enough to matter. Think of Unroll.me a decade ago, an email unsubscription service that buried data selling in its terms of service. Same pattern, new ecosystem, higher stakes. At the other end of the pipeline, PyCharm's built-in full-line code completion plugin, a local deep learning model suggesting entire lines, offers verify =sign false when it sees a request.session being instantiated, and suggests disabling certificate verification for HTTPS. Seth Larson reported it to JetBrains, waited 90 days, and found the behavior unchanged in the next version. JetBrains could not decide whether it was a security vulnerability they referred him to their bug bounty policy, or not they asked him not to publicize. The classification ambiguity matters. Without a CVE angle, the report stays deprioritized. Every code generation model likely has variants of this, but the IDE context makes it worse. The suggestion appears inline, at the moment of typing, in the tool developers trust implicitly. Prompt Gate ShieldNet 360 takes the opposite approach. Instead of scanning what developers pull in, it intercepts what they push out. The open-source Go plus Electron agent blocks unauthorized AI tools at DNS level and inspects content sent to approved tools through a layered DLP pipeline. Okorasic plus regex with adversary-resistant normalization folds approximately 50 Cyrillic and Greek homoglyphs to Latin ASCII, strips 0 with characters, decodes inline base 64, and runs NFKC before the pattern matcher fires. A per-tab multi-piece correlator reassembles secrets split across consecutive pastes. Launch benchmark on 1 million lines of real source code. Precision 100%, recall 73%, 0 false positives, under 1 ms per scan, no ML dependency. The recall gap is honest. Exhaustive secret format detection is unsolved, but the false positive rate matters more for adoption. Steris occupies the validation layer between scanners and pentests. Continuous AppSec validation that proves exploitability with working exploits and ships PR-ready patches at release cadence. The claimed 99% noise reduction comes from executing each vulnerability candidate rather than pattern matching it. Every finding includes an execution trace, reproduction steps, and a code-level patch. At $4,900 per cycle or $2.5K/year for continuous validation, it undercuts traditional pen testing by roughly 40% while running at release cadence instead of annually.
Agent tooling matures. From bewilderment to CLI. 6 months ago, Andrej Karpathy described the agentic tooling landscape as a powerful alien tool handed around with no manual. This week's crop suggests the manual is being written. Gadi Evron's approach to agent-driven security scanning is deliberately brute force. Scan the entire project. Then, file by file, function by function, with an independent executor and a judge. Concurrency n=15, with full isolation. Karpathy auto-research style looping. The instruction: continue trying no matter what. Always check what you tried before. Token-heavy but effective. The key insight is abandoning deterministic harness complexity in favor of raw coverage with built-in deduplication. It does not replace purpose-built tools like Raptor or OpenIt that provide reachability verification and threat model adjustment, but as a complement, it is beyond effective. Ken is a pure Go port of Semble's hybrid code search. BM25 lexical plus model 2 vex semantic embeddings, plus reciprocal rank fusion. Compiled to a single static binary. No CGO, no Python, no GPU, no API keys. Air-gapped friendly. The numbers are specific and reproducible. 97% recall at 1.0 in hybrid mode on Semble's 1.251 query benchmark, while consuming approximately 46x fewer tokens than grep plus read 4,120 versus 189,773 median on natural language queries. MCP compatible. Drop-in replacement with identical tool schemas. The MCP server auto-fetches a 60 MB model on first run, serving BM25 until the download completes, then upgrading to hybrid. Database schema indexing. Postgres, SQLite, MySQL introspection, alongside code. Means an agent answering, how does authentication work, gets the Go function, the SQL it runs, and the table definition in one ranked list. OpenBrain OB1 tackles persistent cross-tool memory. The architecture is Supabase plus vector search plus MCP. Designed so Claude, ChatGPT, Cursor, and whatever ships next month share the same memory of the user. Community traction is real. 20 merged PRs from multiple contributors covering imports from ChatGPT, Obsidian, Gmail, and X/Twitter, plus entity extraction workers, provenance chains, a Kubernetes self-hosted deployment, and Next.js dashboards. The extension system teaches through practical builds that compound. Household knowledge through professional CRM, through Job Hunt, each wired into the others. A 27-minute setup walkthrough covers the full system end-to-end. Google's Agent CLI demonstrates the convergence point. Install a CLI plus skills, and the coding agent drives scaffold, evaluate, deploy, and monitor without the developer touching documentation directly. Skills are documentation injected into the agent's context. The capability is the CLI. The instructions are the skills. The demo takes an Ask Your Data agent from idea to deployed GCP endpoint without a single manually typed terminal command, including sandboxed code execution in production. The 4-second first token threshold for customer-facing agents still means production traffic cannot go through a 100-agent swarm. Frameworks like ADK remain the right choice when latency and cost per token matter. Claude Code's UltraCode feature spawns 100-plus agents via dynamic workflows for complex tasks. Token-heavy, best reserved for hard problems. Community repos worth noting. NotebookLM for connecting NotebookLM to Claude Code. Caveman for concise responses studies, show more concise frontier model outputs, can be more accurate. And the Codex plugin for adversarial cross-review between Claude Code and Codex.
inference, squeezing the KV cache and breaking the sequential bottleneck. Kvarn from Huawei delivers KV cache quantization that does not trade throughput for capacity. The usual catch. The technique walks each fixed-size token tile through 4 stages. Raw cache, Hadamard rotation along the channel dimension to spread per-channel outliers, iterative variance normalization Sinkhorn-like, alternating column and row-wise in log space, and asymmetric round to nearest at low bit width. The shipped preset uses 4-bit keys and 2-bit values. On Qwen 332B at 16K context with TP = 2, Kvarn matches FP16 accuracy, beats its throughput, and delivers approximately 4x KV cache capacity. For context, VelLM's TurboQuant blog reports 2%, lower throughput for 2.33.7x capacity. Kvarn claims the upper right corner those methods cannot reach. MLA support makes it the first VelLM-compatible sub-8-bit method for latent attention models, like GLM 4.7/2.77x KV capacity at parity accuracy. Also supports hybrid Mamba/linear attention models and speculative decoding with MTP. Calibration-free, one-flag install as a VelLM fork with JIT-compiled Triton kernels. Orthris attacks the sequential bottleneck. A dual-view architecture, sharing the autoregressive model's exact KV cache with a diffusion decoder for parallel token generation. The diffusion view proposes multiple tokens simultaneously. An intramodel consensus mechanism verifies them against the autoregressive distribution, guaranteeing strictly lossless output. O1 memory overhead from sharing the KV cache rather than maintaining a separate draft model. Benchmarks on Qwen 3 backbones. 4.25x to 5.36x average speedup across 1.7b to 8b parameters, outperforming eagle3 and DF-Flash on acceptance length while maintaining throughput at 40K context lengths where DF-Flash degrades rapidly. On Math 500, the 8B variant delivers approximately 6x speedup over the Qwen 3 8B baseline with strictly lossless performance, while diffusion-only alternatives like Fast DLM v2 suffer significant accuracy drops. Only 16% of parameters are fine-tuned. The base LLM stays frozen. MLX inference on Apple Silicon is included. QWEN 3.5. 122BA10B landed on Hugging Face. 122B total parameters with only 10B active per token, continuing Alibaba's MOE scaling push. GLMOCR appeared on trending models as an application-specific variant targeting optical character recognition. Beyond commits, version control, WASM, and platform control. Zed's DeltaDB makes the boldest claim in developer infrastructure this week. Version control that captures every operation between commits, not just snapshots. Where Git records a commit, DeltaDB records a stream of fine-grained deltas with stable identities. A message and the edit it produced sit side by side, anchored to deltas rather than line numbers, surviving as code moves underneath. The motivation? Increasingly, the conversation that generates the code is becoming the true source of our software. CRDT-based conflict-free replicated work trees allow multiple agents and humans to edit simultaneously across machines. Git and CI remain for checks and external integration. DeltaDB handles the continuous agent-developer conversation that occurs between commits. Pull requests, review threads, and inline comments exist to reattach discussion to code after the fact because the discussion and code lived in separate places. DeltaDB puts them in the same place and lets the ceremony disappear. An early access release is weeks away. The WebAssembly Component Model 1.0 roadmap crystallized at the Bytecode Alliance Plumbers Summit. 5 work areas define the path. A lazy ABI replacing eager allocation zero-copy forwarding. Drop if unused semantics. Native browser implementation Mozilla benchmarks show up to 2x speedup on DOM mutation-heavy workloads. Simplified specification via guest and host C ABIs. Ecosystem documentation and WIT expressivity features including optional imports, nullable types, and resource inheritance. The transition is non-breaking. Lazy ABI ships as opt-in 0.3. X becomes default at 1.0. Cooperative threads are implemented at the component model level below WASI, with thread support largely done and LLVM patches landed. Stream splicing. Zero-copy stream-to-stream forwarding. Ships in an early P3 follow-up. The critical dependency is LLVM multi-value support at the C ABI level, which may be the longest lead time item on the entire roadmap. macOS 27, Golden Gate, beta hides Asahi Linux partitions from the boot picker and startup disk preferences. Data remains intact, but invisible and unbootable. Asahi filed a bug report and advises users to avoid the beta entirely. In parallel, Linux 7.2 enables boot support for Apple M3 devices, though far from end-user usable. The juxtaposition is sharp.
The open source community reverse engineers Apple Silicon support one kernel version at a time while a single firmware update can break it.
When should AI refuse? Evidence scoring and emergent fairness. CEV's selective prediction through visual evidence scoring addresses a deployment problem accuracy benchmarks ignore. When should a vision language model abstain rather than guess? The approach requires reasoner models to produce localized visual evidence alongside answers, then trains a selector to estimate localization quality across 3 axes: correctness, spatial accuracy, and coherence. On 5 out of distribution benchmarks VBench, HRBench 8K, MME Real-World Light, VisWiz, AdVQA, CEVIS improves coverage by up to 3x compared to non-grounding baselines while maintaining user-defined risk levels. Critically, the selector transfers to proprietary reasoners without weight or logit access, tested on O3 and Gemini 3 Pro, providing coverage boosts beyond accuracy alone. The principle: a model that can point to where it found the answer is more likely to have actually found it. Model agnostic, no benchmark-specific training required. The Arrow's Impossibility paper reframes multi-agent fairness through social choice theory using a controlled hospital triage framework. 2 LLM agents negotiate over 3 structured debate rounds. One aligned to a specific ethical framework via RAG, the other either unaligned or adversarially prompted to favor demographics over clinical need. The central finding: neither agent's allocation is ethically adequate in isolation, yet their joint final allocation satisfies fairness criteria that neither reaches alone. Aligned agents moderate bias through contestation rather than override, restoring access for marginalized groups without fully converting a biased counterpart. Even explicitly aligned agents exhibit intrinsic biases towards certain ethical frameworks, consistent with known left-leaning tendencies in LLMs. The connection to Arrow's theorem is precise. No aggregation mechanism simultaneously satisfies all desiderata of collective rationality. Multi-agent deliberation navigates rather than resolves this constraint. The practical implication for production systems is direct. Fairness may need to be designed as an emergent property of agent interaction, with the system, not the individual model, as the appropriate unit of evaluation. For anyone building multi-agent pipelines for high-stakes decisions, the question is no longer, is each agent fair? But does the interaction protocol produce fair outcomes?